topic in regards to linear, quadratic, and exponential is that you should be able to look at any of these graphs and determine which one it is based off the patterns that you observe. So the first thing that we're going to be talking about is from a table. So here, all we're doing is we've been given the points. This is kind of what your screen would look like on a graphing calculator, and we just need to put them on here. So this one right here, -3 and like a third. Let's attempt to graph that, why not? So we go over 3, 1, 2, 3, up a third. Then we have -2 and just, oh, that's not even a third. That's like even closer. That would be 1, 2, 3, and then almost touching the line. So small, so small. Okay, then we have -2.1, so -2. And like I said before, the variations here are so small. So -1, 1/3. Now we're finally getting to a third. Then we get 0, 1. And now we see that it's opening up. So you get 1, 3, over 1 up 3, 1, 2, 3. Then 2, 9, over 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we were to connect these dots, and if you had to make the decision, what type of function is this? So what I'm looking at is how fast the curve is going, and the fact that this didn't start going back up, it kept getting smaller and smaller and smaller. That to me tells me that this is an exponential function just by observing what I see in the graph. Let's do that for this next one here. Okay, what type of function would this be? So we've got -2, -4. 1, 2, 1, 2, 3, 4. Then we have 1, -3, -1, -3, 1, 2, 3. Then we have -2. Wow, guys, I can count. Okay, never mind, we're good. +1, -1. Okay, so you're seeing that things are happening in this really awesome, can't draw a straight line with this pen, bear with me there. So since we're drawing a line, what kind of function would this be? Linear. Okay, finally we have our third one over here. So we've got -2, +5. 1, 2, 1, 2, 3, 4, 5. Then we have -1, 0. Then we have 0, -3. 1, 2, 3. Followed by 1, -4. 1, 2, 3, 4. And then you'll notice, I'm starting to repeat, which means that this graph is going to be awesomely symmetrical. So what kind of function is this? This would be a quadratic function. Okay, so that's one way to tell. If you are given a table, you can always graph it and see what your image is going to look like. The other way to determine whether it's exponential, linear, or quadratic is for you to examine the outputs of the table. One of the reasons why I had you watch that opening video is I thought that they did an awesome job of comparing the outputs to find the patterns. So if you recall, when they were looking at a linear function, they noticed a very distinct pattern here. All I'm doing is adding 1 over and over and over again. Adding 1, adding 1, adding 1, adding 1. Okay, if you find a consistent pattern like this, that's when it's linear. Quadratic functions have what you call a second difference. So what this means is the first time you look at it, you might not see a whole lot, right? This is -5, this one's -3, this one's -1, -1. My apologies, this isn't -1. It's +1. and then this one would be plus 3, and this one would be plus 5. Now, just looking at those differences, they mean nothing. But if we go a second layer and say, what's the second difference? We go -5, -3. Oh, that's plus 2. Plus 2. Plus 2. Plus 2. Plus 2. Since those are all the same, the second difference indicates that you are dealing with a quadratic function. So let me recall how I got those plus 2's. -5 plus 2 gives me -3. -3 plus 2 gives me -1. -1 plus 2 gives me +1. +1 plus 2 gives me +3. And +3 plus 2 gives me +5. Now, if I didn't know that -1 plus 2 gave me +1, I can subtract it and say, well, what's the difference? So I would say 1 minus -1 would give me +2. So that's another way, if you don't know what it is right off the top of your head, you can subtract the two differences and find your new one. Okay, now with exponents, it doesn't matter if I actually did that and found out what those differences are, there's going to be absolutely no pattern there. But exponential graphs have nothing to do with adding. They're all about multiplying. So let's actually start with our whole numbers because it's a little bit easier to see there, and then we'll go from there. So how do I get from 9 to 27? I multiply by 3. How did I get from 3 to 9? I multiplied by 3. How did I get from 1 to 3? Multiplied by 3. How did I get from 1/3 to 1? Times 3. Times 3. And then this one is so small that you can just assume that it's multiplying by 3. So exponential functions have a common multiplier, which again proves to the point that exponential graphs are going to increase so much faster because they're constantly being multiplied, while a linear function and even a quadratic function really are just being added over and over and over again. So down here are just a few sentences to kind of recap what we just went over. So to examine the outputs, what patterns do you notice? So in a linear function, you're adding a constant rate. With a quadratic function, you're adding a second constant rate. So you have to go 2 rows in to find that. And then with an exponential, you are multiplying by a constant rate. So as x increases, which outputs are eventually increasing the most rapidly? What kind of functions have this feature? So what type of function is always going to reach the highest point the fastest? Exponential. Okay, this response should be automatic by the end of this unit. Exponential functions always will have the fastest rate. So what is the exponential growth rate, the factor you multiplied by? So that's just recapping. In that first example, we were multiplying by 3. What is the rate of change of the slope in the linear function? It was +1, which means that it's increasing, constantly increasing. Can you identify the pattern for the quadratic functions? And then this is where we talked about the first and second difference. Okay, I'm going to go ahead and pause. You know what? No, we're really close. We're going to do one more page of this, and then that's it for today. So we've got part C down here. So it says, now use the points in the table and draw each graph. Identify each graph as linear, exponential, or quadratic. So let's pretend that we didn't have a graph. Okay, so let's ignore that. Let's use those facts, those multipliers, the difference or the second difference, and let's figure out whether it's quadratic, linear, or exponential just from observing the table. So if we look at this first one, let's observe the table. What's happening? Okay, I'm increasing by 5. Now I'm increasing by 3, increasing by 1, decreasing by 1, decreasing by 3, and decreasing by 5. Now, you'll notice that it's a pattern, right? It's going up, up by 5, and then there's a symmetrical down by 5, up by 3, down by 3. And quadratic functions are the only ones that change direction. So even before I'm finding the second difference, I know that this is a quadratic function. So let's find the second difference anyway. So what's the difference between 5 and 3? That's minus 2. 3 and 1, minus 2. 1 and negative 1, minus 2, minus 2, minus 2. Okay, so let's check this one over here. So I notice it's okay, it's starting positive, going to a negative. So let's check our differences. So we've got 8 minus 5, so that's minus 3. 5 minus 2, minus 3. 2, and then to 1 would be another minus 3. I'm going to keep checking it because I don't want to get overconfident. What if they threw me a loop in there? So since those are negative 3 all the way down, this would be a linear function. Okay, look at this last one. What do you notice all right away? The first thing that I see is how nasty these numbers are. Oh my goodness. Yikes. Okay, then what I also see is how these are perfect squares, right? Perfect. The 3 squared would get me 9. So even before I test the multipliers, I'm already deciding that this is exponential, just by looking at some of this crazy townness. Okay, what is the exponential growth rate? The factor that you multiply by. So remember, to find your factor, you would take your second value. So I would take this 0.3704, which is just this nasty, awful number that I can't even write. Let's try that again. 0.3704 over 0.1235, and I end up with a number very close to 3. That 3 is actually going to be applied all the way down. And then it says, what is the rate of change for the slope function? So down here it would be negative, so it's a decreasing graph. What is the second difference of the quadratic function? It was negative 2. That's what we found right here. So you can use these things to make predictions. So you can examine the inputs and outputs of the table without graphing, determining the function is linear, quadratic, or exponential. So these are the kinds of things that I was looking at even before we found the values to kind of back it up. So here, what's some of the first things you notice? Let me share what I'm seeing, and hopefully you're kind of starting to pick up on it. So I'm starting really high, okay, I'm going down, 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 okay, and now I'm repeating. So because I went here and now I'm starting to repeat, this is quadratic. Okay, there's repetition in the pattern. I'm sorry that my handwriting is so bad on this. Okay, table number 2, what are some of the things that you notice? 10, 8, 6, 4, 2, 0. Well, if I go 0, 2, 4, 6, 8, 10, now I'm counting by 2s. So this would just be a steady decrease. I'm noticing that I'm just counting by a series of 2s. So this is linear. And then here, these aren't quite as crazy as the first one, but I'm seeing a bunch of really, really small fractions as my x values are negative. So it's approaching 0. It's never going to touch 0, but it's approaching 0. So that tells me that this is definitely an exponential function. So we are going to stop there for today. Go ahead and go onto Math Excel 7.3. This is actually going to be your last Math Excel assignment. So next, day 4, we'll do a little bit more practice together, just a smidge more notes, just make sure that you feel confident. And then we're actually going to start our review for a quiz that we are going to do on Wednesday and Thursday of next week.